We're working on box C here. We're talking about the steepness of a line. This is still unit 1213, and we're sort of working our way towards the concept of slope. So what you should see on the page in front of you are two distance time graphs. And the question posed up at the top here is which line represents the greater speed? Now what you don't have are two red lines. So what you should see in each distant time graph is you should have two lines, a black line and a red line. So go ahead and just draw in the red line. Let's see if we can make this a little bit bigger here on mine. Okay, so you want to draw in a red line kind of like this. Now in this first graph, looking at that red line and that black line, which line represents the greater speed? If this is a distance time graph of a person moving, which person is going faster, the red person or the black person? Jackie? How do you know that? Distance is higher, time is smaller. How could you tell just by looking at that line? What can you say about this line that lets you know that this person is going faster? What about a line tells you something about the speed, Andrew? The steepness. The red line is faster because it is steeper. It is, let's say, steeper. Now, what about in this second graph over here to the right? Again, I'm going to try to make my red line a little bit bigger here, a little bit darker, kind of like that. Okay. In this one, which person is going faster, the red person or the black person? Cool. Why do you say the red person? Red line is faster. And because the line is steeper, because it is steeper. So in distance time graphs, when we were talking about the speed, we talked about the steepness of the line. What does speed represent in a distance time graph? It represents basically the rate of change, or how fast distance is changing as time is changing. Okay. So greater speed is always the steeper line. Now, let's take a look at two more examples here. You've got one of them there. You've got this black line on your page. Draw a red line that goes straight up and down like that. So we've got a horizontal line and we've got our red line here, which is vertical. Let's start with the horizontal line. What speed does that represent? How quickly is the person whose motion is represented by that black line? How quickly are they moving? Nicole? Yeah, so their speed is going to be 0. Yeah. Speed is 0. Okay? They're not moving. Put that in brackets. Now, what about this red line that I've drawn here? What kind of motion does this represent? Andrew. How fast? How do you know it's really, really fast? It doesn't take any time. So somehow this person moves this distance from here to here in no time whatsoever. If we were to try to calculate their speed, speed is, of course, distance divided by time. Let's say this distance here is, I don't know, let's see, 2, 4, 6, 8. Let's say it's 9 meters. As Andrew said, the time that it's taken them to move this 9 meters is 0 seconds. Who's got a calculator? Work out what 9 divided by 0 is. What is 9 divided by 0? When we calculate the speed. What does your calculator tell you the answer to this is? You're just guessing. You didn't actually work it out. Punch it in. This is audience participation part right here. Liam, what did you get? Got an error. What did you get, Nicole? Yeah. You can't do this. Okay, this is impossible. Okay? And you guys knew that this was impossible when you looked at this distance time graph. There's no way somebody can move 9 meters in no time whatsoever, okay? They can do that in comic books and superhero movies. That's it. You can't do that in real life. So what we say at this point when we've got this line that is vertical is we say that this is undefined. Okay? That's sort of the mathematical term for what their velocity or their speed would be in that case.